Hello, this is a demonstration of hypothesis testing with a binomial distribution for the MEIS1 syllabus, and I'm going to use the June 2014 question 7 as an example. I'm going to follow the probability approach, so I'm going to do the compare probabilities. I'll do a separate demo of critical regions, so I'm just doing comparing the probabilities. Okay, I'm not going to do the first two parts because that's just practicing a binomial. So let's see what the question asks us then by reading through. Okay, first, it is known that on average 85% of seeds of a particular variety will germinate. Okay, and that's our base position. So we know we're looking here at a binomial with p equals 0.85. Okay, we're going to, they asked us to do some probabilities. We're going to carry on to the second part. The following year, Ramesh finds that he still has many seeds left. Because the seeds are now 1 year old, he suspects, this is the important sentence, that the germination rate will be lower. Keyword lower. Not greater than, but lower. He conducts a trial. So he's going to do a trial by randomly selecting n of the seeds and sowing them. He then carries out a hypothesis test at 1% significance level to investigate whether he is correct. Correct in what? Correct in his suspicion that the germination rate will be lower. Okay, what's the first question asking us to do? Write down a suitable, null and alternative hypothesis for the test and give a reason for your choice of alternative hypothesis. So let's work that part of it then. So and do this in red. Our null hypothesis. Okay, so this is the one we are assuming. Yeah, that's from the facts we have. So in this case, and we call it H0. So in our case, P equals, well, what do we know? They've told us that the probability is 0.85. Now, the thing we must write in MEI to get all the marks is we must define what P is. So P is the probability, so you need to write that. Probability that, and what we're looking at here we're looking at seeds germinate. Yep. So there's our germinate, we've defined it. Okay, we always work on the basis that our null hypothesis is that that is true, and we can do all our statistics off it. Now, what's our alternative hypothesis? And here they're asking us to justify it. So we call that H1, don't we? Now, what are our choices? We know it's got to be P, and we know we're comparing it to 0.85. But we've got three choices here. We can have greater than, less than, or not equal to. Yeah, different to. What's the question telling us here? They use the word up here, lower. That's really important. So what we're interested in, we're interested in a probability that's lower. It actually, so it's going to be less than 0.85. They actually asked us to give reasons here, and we've got to get a mark for giving a reason. So let's just write out a piece of simple language that explains that. So Ramesh suspects germination rate is lower than, what was it, the historic, or 0.85, yeah? So therefore, we're investigating whether the P, which is the probability that goes with that germination, is less than 0.85. Okay, does that help us as a starting point? Good. It also helps us determine how many tails we have for our test. So that tells us whether we're interested in whether it's greater than or less than, i.e. extremely high, extremely low, or whether if it was not equal to, then we'd be interested in not either end, wouldn't it? It doesn't matter whether it's higher or lower, it just has to be different. Now in this case, they've told us that we've worked out that p is less than 0.85, and because of that, we're on a one-tailed test. We're only interested in that end where p is lower than. We're not interested in p being higher. So that's the first part of our work. Okay, let's now carry on and look at our test statistic. So what's it told us in this question? Test statistic. Well, our test data we looked at earlier. So we've completed part 2 there, haven't we? And what we've done, before I move on, is we've got points for writing down the probability. There's 4 points here. We've got the probability that we've defined the probability, which is that p equals the probability that seed will germinate. We've put down an H0, we've put down an H1, and we've given a reason, and we got a point for each of those. Okay, so now we're on to part 2, and what have they told us about our test statistic? Well, here it is. In a trial, that's our test of n equals 20, Ramesh finds that 13 seeds germinate. So that's our test statistic. Yeah, that's what we've got. Okay, so in binomial terms, we've got 13 of 20. Yeah. Okay, so that's really useful. That gets us on the go. We also know that we're looking at a binomial here, don't we? So the binomial is, in the trials, was 20, and our probability we're using comes from our null hypothesis 0.85. Yeah, and what we'd be interested in is looking at our actual test statistic compared to what we expected. So let's just move up and have a look at that. So what's our expected value? Our expected value for that binomial is, expected value is NP, which is 20 times 0.85, which would give us equals 17. Yeah, so we're expecting 17 to germinate. We actually only had 13 germinate, and therefore we're interested in 13 or less. We want to be more extreme. We need to be further away from 17. Okay, let's have a quick look at our significance level. Significance level here, they told us in a question our significance level was, let's have a quick close up and pick it out, a 1% significance level there. So there's our 1% significance level. So our significance level is 1%. If it was a two-tailed test, we'd have to split that equally, but actually it's a one-tailed test, so we know we're putting all of that at one end, isn't it? So we've got 1% at the, which end are we interested in? We're interested in the lower end because we were looking at p as less than 0.85. We agreed on that. So here we have all the information we now need to carry out our test. Okay, in order to do that, I'm going to draw out a line because I think it's the best way to see everything we've derived and put it out in a form that we can look at visually. Okay, so what were the possible number of seeds germinating? Well, our low end was 0 of our binomial and our top end was 20. We expected 17. That's quite a high number there, isn't it, towards the right hand end here. And that's our, effectively, if our H0 were true, that's where we'd be starting from, isn't it? If our H0 is true, we'd expect 17. So that's our start point. Okay, so what do we actually get here from our test statistic? We actually got from our test statistic, we actually got our 13, didn't we? So look, there's our 13 there. So we actually had 13. So we're on this side, we're on the lower side. That's our test statistic. We actually had 13. So we're interested, which area are we interested in? We're interested in a more extreme probability in our test statistic, so we're interested in going that way, aren't we? Any test statistic, if we'd actually had 13 or 12 or 10 or 9 or 8, right down to 0, would have been further away from our norm. It'd have been more extreme. So what probability are we going to calculate? We're going to calculate the probability that x is less than or equal to 13, and we can use our calculator for that. So here's our calculator emulator. So I've got my emulator up here. Now our test statistic, that's our X, number of successes is 13, so we put our 13 in there. The number of trials was 20, so we've got our 20 there, and our probability was 0.85, so all we need to do is bang there, execute, and here's our number. Our probability of getting 13 or less, which is what we're looking for, is, and it will disappear when I type this button, so I better look, 0, here we go, 0.0219. So that's our probability. Just have a quick look on there so you've all seen it again. But that's our probability of getting 13 or less. So I'm going to write that probability here under there so you can see it, 0.22. Okay, what's our significance level here? Our significance level was 1%. And so which side of the 0.22 is that? It's going to be on this side because it's lower, it's further away, isn't it? There's our significance level. It's more extreme. So our test statistic in the green is greater than the significance level. So it's closer to our H0. So the question for us is there significant evidence from what we've just seen on the test statistic of 13 that the probability is less than 0.85? And the answer is no, there's not significant evidence. Why are we doing that? Because if we just do our comparison a minute, our significance level at 0.01 and our test statistic was actually greater, wasn't it, at 0.22. So there's not significant evidence. Our green line there, our test statistic, is closer to the H0 than it is to our significance level, which is our critical region. That will be where we get an H1. So the first thing you need to do is write that statement down. Second thing you need to write down and is, so we're doing, it's not significant, our H0 is accepted. Because it's not significant, we're saying there is not enough evidence. This is the wording that we have to use in MEI. To suggest, you could also write to indicate that. So what are we testing out there? In this case, when we're going to pick up the text, it is that the germination rate is lower. Okay, so it's important that you write out it's not significant, you get a mark for that. You get a mark for doing the comparison of the significance level with the test statistic, and you get a mark for writing there's not enough evidence to suggest. And you see the alignment there, that if it's not significant, we've got not enough evidence and we accept H0. The alternate will be there is significant evidence, you're rejecting H0, and then you have enough evidence to suggest that. So those all fit together. Finally, here's a little summary I've done of the different stages, and they're color-coded. So we're going to go through and calculate our hypotheses. Important to remember to write down the definition of your probability, and then your H0 is always P equals our known value. You then have to look at your alternative, and you have to decide whether it's greater than, less than, in which case you've got a one-tail test, or it's different to or not equal to, in which case you've got a two-tail. You do your test statistic using your binomial, and remember to look whether you're looking for a high or low number compared to the expected value. They give you the significance level, you just need to remember whether you're splitting it or not, whether you'll split it if it's a two-tail test, and then you have to write out all your comparison of your test result down the bottom here. So I hope that's of use to you. Best of luck.